Out there, in the cold darkness of space, our neighbor Mars isn't traveling alone. It's accompanied by two tiny companions, two little worlds that cling close to the red planet. These are not grand spherical moons like our own. Instead, they are among the smallest moons in our entire solar system, lumpy and potato-shaped, more like cosmic rubble than majestic celestial bodies. Their names are Phobos and Deimos. These two moons have been circling Mars for billions of years, silent witnesses to the planet's long and mysterious history. They are cosmic footnotes, yet they hold clues to the very formation of the planets themselves, waiting for us to come and read their story. For centuries, we looked at Mars through our telescopes and saw nothing but a solitary red dot. The idea that Mars might have moons was just speculation, a story told by writers like Jonathan Swift, long before we had the technology to see them. It wasn't until 1877 that the American astronomer Asaph Hall, using the powerful Great Equatorial Telescope at the U.S. Naval Observatory, finally spotted them. Imagine his focus, night after night, carefully scanning the overwhelming glare of Mars, searching for faint specks of light. He found Deimos first, and then, just a few nights later, he confirmed the existence of the even closer moon, Phobos, completing the Martian family portrait. Hall drew their names from the rich tapestry of ancient Greek mythology, a tradition that connects our scientific discoveries to the stories our ancestors told to make sense of the cosmos. In the myths, the god of war, Ares, known to the Romans as Mars, rode into battle accompanied by his two sons, Phobos and Deimos. Phobos was the personification of fear and panic, while Deimos represented dread and terror. These names seemed fitting for the companions of the blood-red planet of war. It's a poetic link, a reminder that our quest for knowledge is deeply human, woven with the threads of imagination and history that stretch back thousands of years. These moons are truly tiny on a planetary scale. Phobos, the larger of the two, is only about 22 kilometers, or 14 miles, across its widest point. That's small enough to fit comfortably inside the boundaries of a major city. Deimos is even smaller, a mere 12 kilometers, or 7.5 miles, in diameter. Their small size and irregular lumpy shapes tell us they lack the gravitational might to pull themselves into a sphere, the standard shape for large celestial bodies. They are not grand orbs but rugged primordial chunks of rock, tumbling through space in the gravitational grip of their parent planet, holding on to their secrets. When we look closer at these two little worlds, through the eyes of our robotic explorers, we see surfaces that tell a story of a violent past. Phobos is scarred and battered, a testament to countless impacts over the eons. Its most dramatic feature is a massive impact crater named Stickney, which is nearly 9 kilometers, or 5.6 miles wide. This crater is so enormous relative to the moon's size that the impact that created it must have come perilously close to shattering Phobos completely. Radiating from the crater are long, shallow grooves that stretch across the moon's surface, like cosmic stretch marks. Scientists are still debating what caused them. Perhaps they are fractures from the Stickney impact, or maybe they are formed by the constant gravitational pull from Mars. Deimos, the smaller and more distant sibling, presents a gentler, softer appearance. It is also covered in craters, but they appear much smoother, almost as if they have been filled in or worn down over time. This is because its surface is blanketed in a thick layer of regolith, a fine dust of pulverized rock created by micrometeorite impacts over billions of years. This dusty layer has muted its features, giving it a subdued look compared to the stark, rugged terrain of Phobos. Deimos looks less like a battle-scarred warrior and more like an ancient stone, weathered by an eternity of exposure to the harsh environment of space, its sharpest edges softened by time. What are these little moons made of? By studying the way they reflect sunlight, we've discovered that they are very dark, among the least reflective objects in our solar system. They appear to be composed of what we call carbonaceous chondrite material, a type of rock rich in carbon and similar to the composition of C-type asteroids. These are some of the most primitive materials in our solar system, the leftover building blocks from the dawn of planet formation, about 4.5 billion years ago. This composition is a major clue in the mystery of their origin, suggesting they may not have been born with Mars, but instead came from somewhere else. Imagine standing on the surface of Phobos. The ground beneath your feet would be this dark, carbon-rich rock, a substance that has changed very little since the solar system was young. You would be standing on a piece of cosmic history. Mars would dominate your sky, a colossal reddish orb hanging overhead, appearing over 6,000 times larger than our full moon appears to us from Earth. These moons are more than just rocks. They are time capsules, preserving the raw ingredients of our solar system, and they offer a spectacular, up-close view of the magnificent red planet they call home. The orbits of Phobos and Deimos are as strange and fascinating as the moons themselves. Phobos is locked in a frantic, hurried dance around Mars. It hugs the planet incredibly tightly, orbiting at an altitude of less than 6,000 kilometers, or 3,700 miles, above the Martian surface. That's closer than any other moon to its planet in the solar system. It whips around Mars in just over 7.5 hours, completing more than 3 full orbits in a single Martian day. This rapid pace creates a bizarre spectacle for any observer on the surface of Mars. Phobos would appear to rise in the west and streak across the sky to set in the east just a few hours later. Deimos, on the other hand, performs a much more slow and stately waltz. It orbits much farther out, at a distance of over 23,000 kilometers, or 14,500 miles, from Mars. Its orbital period is about 30 hours, which is just a little longer than a Martian day. From the surface of Mars, Deimos would not look like a moon at all, but more like a very bright star, slowly drifting across the night sky. It would take nearly 3 days to cross from one horizon to the other. The two moons present a study in contrasts, one a frantic sprinter, the other a slow and patient marathon runner, both locked in a gravitational embrace with their parent planet. But the dance of Phobos is a doomed one. Its tight orbit lies inside what we call the synchronous orbit radius, the distance at which an object orbits at the same speed the planet rotates. Because Phobos orbits faster than Mars spins, the tidal forces between the planet and the moon are causing Phobos to slowly spiral inward. It is getting closer to Mars by a rate of about 2 centimeters every year, or about 2 meters every century. This may not sound like much, but over cosmic timescales, it seals the moon's fate. The pull is relentless and unforgiving. In about 50 million years, this cosmic dance will come to a catastrophic end. There are 2 possible fates for Phobos. It may continue its inward spiral until it crashes into the surface of Mars, creating a massive impact crater, or more likely, as it gets closer, the powerful gravitational pull of Mars will overwhelm the moon's own gravity, tearing it apart. Phobos would be shredded into countless pieces, which would then form a spectacular, temporary ring system around Mars. For a brief moment in cosmic time, the red planet would be adorned with a ring, a fleeting monument to its long-lost moon. Where did these 2 strange little moons come from? This is one of the great unsolved mysteries of Mars. The leading theory for many years has been the captured asteroid hypothesis. Because their composition so closely resembles that of C-type asteroids found in the asteroid belt between Mars and Jupiter, it seems plausible that Phobos and Deimos were once wandering asteroids that strayed too close to Mars and were captured by its gravity. This would make them cosmic orphans, adopted by Mars long ago. However, their nearly circular orbits, aligned perfectly with the Martian equator, are difficult to explain with a simple capture scenario, which would likely result in more irregular, tilted orbits. This has led scientists to consider a more dramatic origin story: the giant impact theory. In this scenario, early in the solar system's history, a massive object, perhaps a large asteroid or a protoplanet, smashed into Mars. The collision would have ejected a tremendous amount of rock and debris from the Martian surface into orbit around the planet. Over time, this cloud of debris would have slowly clumped together, or accreted, to form one or more moons. Phobos and Deimos could be the last surviving remnants of this violent birth, true children of Mars, born from the planet itself. This theory better explains their tidy equatorial orbits, but awaits more evidence. To solve this mystery, we can't just keep looking from afar. We need to go there, to touch these worlds and bring pieces of them back to Earth. Several missions have flown by Phobos and Deimos, giving us tantalizing glimpses, but we have yet to land. The Soviet Phobos 2 mission in 1989 returned some data before contact was lost, just before it was set to deploy a lander. Now, humanity is preparing to go back, with a bold new mission designed to unlock the secrets of their origin once and for all. This mission represents our next great step in understanding our planetary neighbor. The Japan Aerospace Exploration Agency, or JAXA, is leading the charge with its Martian Moons Exploration, or MMX, mission, scheduled to launch in the coming years. The MMX spacecraft will travel to the Martian system, orbit both moons, and then land on the surface of Phobos. It will collect a sample of the moon's regolith and then return it to Earth for detailed analysis in our laboratories. By studying an actual piece of Phobos, we hope to determine its age and composition with incredible precision. And finally answer the question, are these moons captured asteroids or the children of a giant impact? The answer is waiting for us, written in the ancient dust of these tiny, mysterious worlds.